Hey, greetings and welcome, friends. Today we're going to talk about order of operations, just evaluating numerical expressions. We might even get to some things with variables in it, but we're going to be talking about the agreed upon societal norm across all mathematicians as to when do I do addition, subtraction, or multiplication, exponentiation. Maybe you've never heard of it referred to that way before, right? When do I do these things when multiple things are happening in the same problem? So for instance, up here, it says order of operations. So expressions like 1 plus 2 times 5, how do I know which to do? Or in this case, 10 divided by 5 plus 14 divided by 2. How do I know which operation, right? Do I do like 1 and then 2 and then 3? Do I just pick my favorite? Maybe that's something you never even thought. Does it even matter? Could we all do this problem like 5 different ways and will we all get the same answer anyways? And it turns out it does matter. And so mathematicians have defined an order, a sequence for us to do this correctly. So it says the expressions like these are called numerical expressions. So they're just made up of numbers and mathematical operations.
Are we supposed to write this down?
No, not all of it, or just anything that'll be helpful to you. We'll get to some examples in a little bit that'll be more helpful. So let's see, numerical expressions contain a combination of, like I said, numbers. So that's like the 1, the 2, the 5, right? 10, 5, 14, and 2. Numbers and operations. All right, operations are the plus, the times, the divide, the plus here. Man, I'm going to get better at drawing as my videos go on, right? Such as addition, subtraction, multiplication, and division. In terms of an exponent, if I had like a little 2 here, there isn't a symbol for exponent. I mean, other than like on a calculator, if you use like the little, they call it a caret. There isn't a symbol for that, but like the operation is implied when you have the little number raised and it's smaller font sort of thing. So let's see. So when you evaluate an expression, you find its numerical value. So instead of writing out like this, I'm going to say, could I like just have one number that represents all of that combined? And that's what I do when I evaluate. To avoid confusion, mathematicians have agreed upon the following order of operations. What are the operations? These little orange guys, right? So which operation takes place first? So here we go. This is the concept summary. So step 1, simplify all the expressions inside grouping symbols. So what are some grouping symbols that you know of? Anybody? What groups things together?
Pemdas?
Yeah, in Pemdas, what does the P stand for? Parentheses. So parentheses are grouping symbols. Sometimes you'll have square brackets. Sometimes these ones, it takes me a long time to get used to this. The curly brace or bracket, I think. I don't know. It's just words. Another type of grouping symbol that you might not be aware of is a fraction bar. So if I have like a plus, or actually let me not confuse it, 1 plus 2 all over 3, this fraction bar is a type of grouping symbol where it's implying that the top and the bottom are separate pieces. Okay, so those are grouping symbols. And then it says do all multiplication and, wait a minute, and or divisions? So wait, can I do division first sometimes, guys? It appears to be that's what they're implying. And it says from left to right. So that takes place in priority from left to right. So I might have multiplication and then division. Other times I might have division, then multiplication. Let's see. Oh, here we go. Right, and it takes place from left to right. So I process through a problem from left to right. Okay, and then do all additions and or subtractions from left to right. Okay, so that's the same idea. So sometimes subtraction can come first. It's not necessarily add and then subtract, even though Pemdas might suggest it. It's just from left to right. Now there is an operation in here that wasn't listed, which I'm gonna communicate to you, which is exponents. Exponents would occur after step 1, before step 2. All right, so there's the order of operations. All right, so you guys have seen this before, and like we just said, we had the idea of Pemdas as a little acronym to recall that. However, recall that M and D is L to R, okay, and A and S is L to R, right? So those can be D and M and S and A, okay? And then E is exponents, and P, here we have it standing for parentheses, but it really can be any grouping symbols. Any grouping symbols. All right, so here they call it, right, P for parentheses. And this is actually going to be valuable, one, so that we are all getting the same answer when we do the problem. We all have this agreed upon order of operations. But it's also going to be helpful when I'm solving equations for an unknown variable, okay? Which, I mean, it's not going to show up, you know, for another week or so, but I'm actually going to end up needing to know this order because I'm going to be doing it in reverse, oddly enough. But before we get there, let's try a couple of examples here. We'll do this right here like so. Wah, 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 wah. All right, so here we go. Here's some examples. So these ones you guys could write down so it'll be more helpful. Let's first go through and do problem A. So let's see, which operation should I do first? Addition or multiplication? Multiplication. So I'm going to just kind of like note that I'm doing this first. So 4 times 5, I'm going to get 3 plus, let's see, 4 times 5 is 20. And now there's only one operation left, and 3 plus 20 is 23. I believe that's my answer. Now, just to point out, because I think it's worth seeing, if I did 3 plus 4 first, so this is the wrong way. Oh man, that's an ugly 5. There we go. If I did 3 plus 4 first, what do I get? I get 7 times 5, and 7 times 5 is 35. So notice the order matters, right? I mean, if we're going to use math as a language, we got to make sure we're doing it the correct way, in the same way as each other. So the order did matter here, and 23 was the right answer. Okay, how about this next problem, part B? Which operation should I do first? Division. But isn't Pemdas MD multiplication and then division? It could be either or. So which one do I choose and why? Division because why? Because I'm doing, yeah, left to the right. So the division shows up first from moving left to right. So I'll do 18 divided by 3, which is 6. And then 6 multiplied by that 2 is 12. All right. Oh man, guys, this problem's getting crazy sauce here. Yikes. All right. Yeah, we will. Don't you worry. Don't you worry. So let's see. 2 plus 9. Which operation do I do first? I target the grouping symbols, so I'm going to work in the smallest inward set of grouping symbols. And within that, bless you, if there was multiple operations within the parentheses, I have to do Pemdas within the parentheses, okay? But here there's just one operation, so I'm going to do 2 plus 9. So let's see. So I'll have 6 times 2 plus 9 is 11, minus 3 times 8. Now, when I have this 6 outside parentheses, what operation is going on here? Is this plus, minus, subtract, exponent, division? What's implied between 6 and 11? Does anyone know? Yeah, it's implying multiplication. So you don't have to write that dot, but this is implying multiplication. So let's see. So I've got a multiplication, I've got subtraction, and I've got multiplication. What should I do first? Which multiplication? The one on the left. Now technically, if you're getting fancy, you could technically do both simultaneously because I realized they were kind of isolated from each other by this minus sign, but let's just do this the normal way first before we start learning tricks. So 6 times 11 is 66, minus 3 times 8, and let's see, multiplication again first. 66 times 3 times 8 is 24, and now that's the only operation remaining. So 66 minus 24 is going to be 4 to 2. Do we have concurrence on this? You guys agree? Is my subtraction right? For all the internet, add in the comments if you're like, hey, dude, Mr. Waddy, you got that wrong, friend, and hopefully we'll be able to fix it. All right, part D, here we go. Oh my goodness, guys, this one's terrifying. This is the boss fight of order of operations, right? Like, we've learned a bunch of skills fighting its minions, and now we've like approached the top of the tower or the bottom of the dungeon, whichever. And this is the boss fight. I got to use all of my skills combined. What do I do first? Yeah, so this is the innermost parentheses. This one's equally inner, but this one has no operation there. So I'm going to do 15 minus 9. I agree. So let's see. So this equals 4 times brackets. 15 minus 9, what's that? 6 plus 8 parentheses 2 brackets. 8 parentheses 2. What operation is implied there? Multiplication. That's what's implied. So working inside these brackets now, 8 times 2 is 16. So 6 plus 16. And working still inside the brackets, even though this is implied multiplication, this addition is going first because it's inside the grouping symbol. So let's see. So that's going to be 4 times 22. And 4 times 22 is 88. 88. All right. Wow. Okay. All right. So with the more operations showing up here, there are more combinations for which I could do it in the wrong order. Like I said, eventually we'll learn some tips and tricks to be able to do this a little bit different. But right now, I definitely want you to, just commit to getting it the right way every time, and then we'll learn how to do things more efficiently. Let's see, there's my scroll bar. Okay, so let's see, let's do one more concept and an example. So let's see, evaluate expressions. All right, so algebra, this is the first time we've seen this word in Algebra 1. Algebra is a language of symbols. One symbol that is frequently used is a variable. Okay? A variable is a placeholder for any value. Wow. As shown above, h represents some unknown number of hours. I clearly don't have that. So I'll have to make up a problem where you have h. Let's see, what if I have pay, let's say you got paid $100 at the end of the week, and let's say that was equal to your, I don't know, $10 per hour multiplied by h. So here's an equation where this was your pay, this was your rate, and this was h, in this case representing hours. Okay, so it's possible to have variables represent a variety of numbers. In this case, there's probably only one way that could work. But if I wanted to just have a general equation to calculate my pay, I could say, hey, what's my weekly paycheck going to be? It's going to equal my $10 per hour multiplied by h. And then I could plug in any number for h. So some week I work 8 hours, some week I work 12 hours, some week, man, maybe 73 hours. I think that's the most hours I've ever worked in a week. And then what I plug in for h, I then just evaluate it, and it's going to give me what I want to know. All right? So a variable can represent any number, and we're going to have you evaluate some expressions when we'll give you a designated number for a variable here. So let me just show you, let's see, where's my scroll bar? There it is. See, it kind of hides on me there. It's done be sneaky. Let's see. So here's some variable names. Variables, mathematicians, we use letters to represent variables. Most often we use lowercase letters to represent variables. sometimes we'll use capital letters. You might have seen, for instance, the formula A equals B times H. A capital letter is sometimes a variable that represents kind of a more complex topic, like base and height of a rectangle or length times width of a rectangle. Those are like kind of one-dimensional topics where A was a bigger idea. It was found by including multiple variables in it. But let's see, most of the time the letter X is used as a variable. Here you could have, right, H. If there's no operation written between a number and a variable, it's implying that you're multiplying. Okay? If you have two variables side by side, that's not a single name for like the variable mn. That is two separate variables that are being implied to be multiplied. And y over 3 is implying I'm dividing whatever y is by 3. So these are called algebraic expressions. So earlier we had numerical expressions, which were made up of numbers and operations. Algebraic expressions also include variables. Okay? So that's the only difference, is it has this little variable piece here. Okay. So one of the things that we can do is, if I want to evaluate an expression, sometimes you'll have an algebraic expression, but I'm going to be like, well, tell me what it is when the variable is 7, or when the variable is 2, or when you did work 73 hours that week. And what we'll use is the substitution property to evaluate that. So let's see. So here we go. If two values or quantities are equal, then one quantity can be replaced by the other at any time. They're interchangeable. Okay? So if I have two things that are truly equal, then I can swap them out anytime. My classic example is Indiana Jones, Raiders of the Lost Ark. In the beginning of the movie, there's like, he goes through this dungeon and there's this little like temple and there's this little golden statue on a pedestal, and then what does he do? He gets this bag of sand and he kind of weighs out the sand, estimating the weight of the statue, and he swaps those two things. And the idea is that if those two things are equal, then he could replace one with the other, the t'other, right? In this case, well, actually, I won't spoil this excellent movie that I'd recommend you go see, but the substitution property works every time if, in fact, they are truly equal. Symbolically, it says for all numbers a and b, if a equals b, then a can be replaced by b. So I can swap them out. Bless you. So let's do this example. We might have time for a couple examples. We'll see of this idea here.
Not to be rude or anything, but I don't think anyone's going to want to have to.
Oh, don't you worry, man. It happens all the time. 58,000 views, my friend. 58,000 views. So, but no, I'm here to help, man. I'm here to help. So let's see. It says evaluate expressions. Evaluate x plus y minus 9 if x equals 15 and y equals 26. So if x is really equal to 15, that means I can replace x with 15. And if y is really equal to 26, I can replace y with 26. So when we substitute, just like Indiana Jones had his sand in a bag, he didn't just like throw a pile of sand on the pedestal. You sometimes, it's a really good idea to substitute with parentheses. The parentheses is kind of like your bag holding it together. In this case, it wouldn't matter, but I'll just do it anyway. So I'm plugging in 15 for x. I'm plugging in 26 for y, and here we go. So I've substituted, right? I've replaced those things, and this is still mathematically equivalent because I told you earlier those things are equal. So let's see, what do I get? So 15 plus 26 minus 9, Pemdas, which do I do first? Which operation? The addition. So let's see, 15 plus 26, well, let's see, 26 plus 10 is 36, plus another 5 is 41, I believe. And now I can do the subtraction. 41 minus 9, let's see, 42 minus 10, I believe is, 32 is the way that I would have decomposed those numbers. So what I've done is I've evaluated this algebraic expression when I had very particular values for x and y. So I think that's all we have time for today, internet friends. As always, thank you for watching. It's always a pleasure. It's great to be back. Bye-bye.